Hello, welcome to part 4 of this series about object-oriented programming in Python. In the previous 3 episodes I discussed object-oriented as a general concept and showed you how to create a class in Python. We learned the difference between a class and an instance, and we ran through some exercises to learn how to write methods. In this video I will get a bit deeper into the class-instance relationship. This may sound a bit far from the daily programming issues that you have, but I believe every Python programmer has to master these concepts. They are the core of everything you can do in Python, so definitely worth knowing. As always, you will find the Python notebook files in the companion repository. You will find the URL in the video description. The first concept I want you to learn is that instances are writable. In this code, I just instantiated the class lift and created the variable lift1 with the attributes 1 and closed. As we learned, we can access the attributes stored by the init function with a dotted notation. If I try to write one of these attributes though, Python doesn't complain. It just obediently replaces the former value with the new one. This is one of the traits of Python, that few things are actually forbidden or enforced by the language, at least less than in other languages. This is clearly a double-edged sword, as less restrictions mean more creativity but also less control. But we can discuss this in another video. For the time being, remember that attributes are writable. Not only attributes, the class itself can be written. For example, we can add a new attribute color on the fly. If you think about it, this is nothing different from what the init function does. That, being a method, can work on self, which is the instance it belongs to, but in the end, it is just creating a new attribute on the fly. This is where Python departs from the traditional approach of having declaration of the type and an implementation. In Java, for example, you have to declare the attributes of an object beforehand, and if you try to initialize an attribute that doesn't exist, the compiler fails. Python, on the contrary, just adds the attribute to the object. Let's go back to the instantiation action. Two different instances of the same class are not connected, even when they have the same values. Such instances are just like two people with the same name, who still keep their own identity and are independent from each other. Here I instantiate the lift class twice with the same two values, 1 and closed. The two instances stored in two different variables are separate, and you can tell this checking the ID. The built-in function ID returns the memory position of the object, so it is a pretty low-level action, but you will not have to work with IDs generally speaking. It is worth having a look now just because this makes us understand what Python does. In general, if two things have different addresses, they are different. It is pretty much the same as two people standing at different coordinates. They cannot be the same person. To further show that there is no connection between the two instances, let's change the value of an attribute in the first instance and see that the same attribute didn't change value in the second. Python is a language that has introspection. The dir built-in function shows you what an object contains in terms of methods and attributes. If you run dir on lift1, you can see that there is much more than you thought inside an object. It is reassuring to see, however, that the list contains attributes like floor and status, or methods like init and open that we defined when we build the class. We will not review now everything that Python stores inside an object, but there is an interesting thing to discover. How does Python know the class of an object? Given an instance, how does Python keep track of the class that was used to create it? The answer is surprisingly simple actually. Python writes the name of the class inside the instance in an attribute that is called dunder class. At this point you understood that the double underscore prefix and suffix is used to mark special attributes or methods. In general, it is better not to touch special attributes, as they are often vital for the object itself, which could misbehave if we change low-level elements. Anyway, the function type that we used previously just prints out the value of the dunder class attribute. You maybe noticed that the value of this attribute is not a string though. There are no quotes, and the angle brackets shows us that we are looking at something special. It turns out the dunder class attribute doesn't contain the name of the class, but a reference to the class itself. In Python, instances are connected with the class at runtime. This is extremely important because it's the source of a lot of Python's expressive power, and also a lot of bugs in Python programs. So let's look at it in detail. It may seem that the class is a sort of template used to create instances, as if the instance was a photocopy of a master instance that is then discarded. Instead, in Python, the instance is an object that is still connected to the class and that uses the class all the time. The closest example in real life is that of a local store that can sell things that are not physically there just because it still has a connection with the central store that can deliver sold items on demand. The example is actually closer to the way Python works than you may think. Let's try to change the class live and see what happens to instances. Here I added an attribute maxWeight to the class. Pay attention, I added it to the class lift, not to one of the instances. Suddenly, however, both instances have this attribute. As you can see, the example of the local store is not that far from the actual implementation of Python. When you access an attribute, what happens behind the scenes is that Python runs a special method called dunderGetAttribute, which tries to find the attribute in the instance. If the attribute is not there, before raising an error, this method tries to retrieve it in the class. What happens if we define that attribute in one of the instances then? Well, here I created the attribute maxWeight in lift1 with a different value, 400 instead of 120. As you can see, lift1 returns 400, while lift2 keeps returning 120. This is a practical demonstration of what I said about dunderGetAttribute. Since lift1 provides the attribute, there is no need to check the class, which is instead the case for lift2. If we change the value of maxWeight in the class, say to 300 for example, lift2 will reflect the change, while lift1 keeps returning its own value. You can actually provide so-called class attributes when you create the class. It is sufficient to add the attribute at root level without mentioning self. In this case, all instances of the lift class will have the same value of maxWeight, which is shared with the class. If the value in the class changes, the value in each instance changes. If an instance overrides the value, the class and all the other instances will remain untouched by this change. So what you have to take away from this lesson is that classes in Python can have attributes, and that they share these attributes with their instances, as long as instances do not override them. It's time for some exercises that will hopefully help you to better understand what was said, and maybe also make some questions arise. As I said, this mechanism is pretty important for every Python programmer, so make sure you grasp it. Exercise 1. Modify the lift class as shown, where I added a class attribute status with value undefined. Now, create an instance. What value does the status attribute of the instance have, and why? What happens if you change the value of the status in the class? Exercise 2. Modify the lift class as shown, where I added a class attribute status with value closed, but also removed self-status from dunder_init. Now create an instance and check what the value of the status attribute is. What happens if you change the value of the status in the class? Now call open on the instance. What is the value of the status attribute? What happens if you change the value of status in the class? Exercise number 1. So in this case, when we create an instance, the value of the status attribute is the value that we passed to the dunder_init function when we created the instance. This happens because when we run the dunder_init function, which happens when we instantiate the class, that method creates the self.status attribute inside the instance, and this overwrites the status attribute created by the class. So whenever we try to read the status attribute of the instance, the dunder_getAttributes function doesn't need to go and check the class. The status attribute is already there. If we change the value of the status in the class, nothing happens, because as we said, all instances have their own status attribute. Exercise number 2. Well, here we removed the self-status creation in the dunder_init function. So every instance has the status attribute because this is provided by the class. So whenever we change the value of status in the class, the value of self-status in each instance changes. When we call open, however, things are a bit different, because open changes the value of self-status, but self-status is not there in the first place. So open creates the self-status attribute with the value open. At this point, the instance that ran the open method has its own status attribute and is disconnected from the class. So as you can see here, the self-status equal open line doesn't set something that exists already, but creates something new. This is exactly what dunder_init did before. And this is why you have to learn this mechanism, because Python code may deliver surprising results, like in this case, where you are supposed to update a value that's already there, and instead you are overwriting something and disconnecting the instance from the class. In this lesson we learned how Python manages the relationship between classes and their instances. What we learned today is the foundation of everything we will do in Python, even though it will almost always be in the background. So don't worry if you found the exercises a bit odd and complex. I made them so on purpose because I wanted you to understand the mechanism. But as I said, your daily work with Python will definitely be less a puzzle and more fun. That's all for today's video. In the next lesson I will discuss another pillar of object-oriented, which is delegation. Thank you for watching.